Okay guys, so here is the last section of chapter 8, which is dynamic of circular motion. It's continuation of my previous video about chapter 8. So I want to define first of all a new coordinate system, which it's called coordinate system of RTZ. What is RTZ means? It's same as X, Y, and Z. Okay, as we have three dimension, XYZ, we have RTZ, which it is same, nothing changed. Let me tell you what is RTZ means. R means is radial. As we have x-axis, we do have r-axis, which is called radial axis. It's called radial axis. R. Or we can call it, it's okay, also central axis. That means is the axis that goes through the center. Okay, so that means is this, the axis goes through what? Center. Okay, guys, if you remember, for x-axis, usually when we do this, x, we write here is 0, correct? We say anything toward the right direction is positive, toward the left is what? Is negative, am I right? But here, remember, let me write it by different color. What is positive direction? There is nothing about left or right on the circle. What is positive direction for r-axis? So I'm going to write here this, that positive direction of radial axis is toward center. What does that mean? That means this. Watch it. Imagine this is the circle, correct? Now, this is the center. So you have to verify, first of all, center of that rotation. And anything toward the center is positive direction. Any force toward the center, which it is centripetal force, it's toward the center, it is positive. Do not forget this. So here, we're not going to say left side or right side, no. Here on x-axis in chapter 2, 3, 4, we have anything to the right is positive, to the left is negative. So what we have on circular motion, we do have anything toward the center is positive. Okay, keep it. This is very important. So that is called radial axis. The second one, so let me go with black. The second one is t-axis. What is t means? Tangent axis. T means is tangent axis. Okay, that is the axis. Its axis tangent on the circle. On the what? Circle. So what is tangent axis? Oh, okay, it's tangent on the circle. It is tangent on the circle, guys. So this one is radial axis. Then tangent axis, look, in reality here on this picture is this. This is the tangent axis, right? That's the tangent axis. RT. Remember, it's on the circle. It's not up and down, huh? It's on the circle. Okay? So tangent axis, in reality, it is same with direction of motion. It is same as direction of motion axis. It is on the circle. So tangent axis is on the circle. Okay? Now, what does Z means? Z means is Z-axis. Z means is same as we have Y in 2 dimension. It's, up and down axis. It's up and down axis. So here we have anything upward is positive, down is what? Negative. Do not forget this. Z-axis is the same as we had before Y-axis. So RTZ, which is like XYZ. Therefore, watch guys, if let's use right hand. Let's use right hand. So do your hand like this, please. So middle finger is radial axis. So middle finger is toward center. Index finger is tangent axis. And your thumb finger is Z-axis. So you have to do this. You have to do like this. R, T, R. T is index finger and Z is up and down. So R, T, Z. Therefore, let me draw a circle. Oops. If this is circle, so toward the center, it's radial axis or central axis. Okay. On the actually circle is tangent axis, and where is Z? Z is, oops, Y. Z is this. Okay, so this is what I have. R, T, and Z. Radial axis, tangent axis, Z axis. So tangent is tangent on the circle. Radial is toward the center, and Z is up and down. That's why if you do your hand like this, see, R is toward axis. So we can write middle finger is radial axis. We can say index finger is tangent axis. It's tangent on the circle, remember. And thumb finger is what? Z axis. Okay? Yes. So let's do one example. Now, what is the dynamic? Watch, guys. When we say dynamic, what is dynamic means? Dynamic means is sigma F equal what? MA. Remember this. So if we have RTZ, coordinate system, therefore we have to apply what? Sigma F on R axis equal what? Sigma F on tangent axis is equal with what? And sigma F on Z axis equal what? Of course, these are all MA. As I said, this R is same as centripetal force. So let me write it. It's okay, huh? So sigma F on R or sigma FC, either works. So this will be C. So let me correct it to not make you confuse. Okay. So this will be centripetal force or central axis. We don't say CTZ. If you want, you can call it CTZ. It doesn't matter. Or RTZ. Because radial or central, both they are same word. Then this one is MAT. It's going to give you tangent acceleration. Please pay attention. And this one is M what? AC. That means is radial acceleration, AC, tangent acceleration, and acceleration on z-axis. Okay, guys, if object doesn't go up and down, if object doesn't go up and down, if object just has no motion on z-axis, so what does that mean? This means AC is what? 0, correct? If object rotates with constant velocity, AT is 0, okay? Therefore, this is dynamic of circular motion. Total forces on radial axis or on central axis is equal with m vt square divided by r, because we know centripetal acceleration is tangent velocity to the power of 2 divided by radius, correct? Little r, big R doesn't matter, or mr omega square. Sigma ft is mat, correct? Of course, I'm going to put acceleration as a vector. Now there is one thing here, guys, watch. Let me write it by different color. If Vt is constant, then At is equal with what? 0. Keep this one, it's very important. If your circular motion is uniform, then At is 0. Okay? Beautiful, right? What next? Sigma f on z-axis is equal maz, which, guys, acceleration on z-axis, if object doesn't go up and down, is 0. Don't forget this. Do not forget this section, okay? Acceleration on z-axis is 0 because object doesn't go up and down. When you rotate one, if you have one ball, just attach it on one string, rotate it, correct? Object doesn't go, ball doesn't go up and down. It just goes on one circle. So AZ is 0. Let's do one example. Then it will be more clear for you, okay? Example is about tetherball. So let's say this is our example. Watch, guys. Example says this. Excuse me. What is tetherball? Probably you know that in high school. So let's write tetherball is a ball, okay, attached on a string, and other end of string is attached or hanged, you know. Let me write this one. Is hanged by a ring, you know, to a rod. Which string and ball, when ball rotates, it's completely free rotation, so it rotates around the rod. So the ball can make rotation or centripetal. Let's write circular motion, rotation around rod, which it makes what? Circular motion. So far makes sense. So in particular situation, let's say, or yeah, in particular state, the ball makes 30 degrees, let's say, sorry, let's say 40 degrees angle with rod. Okay, regarding its string. Mass of the ball is 500 grams. All right. Find. So let's write below figure. Shows state of the ball. Right. Now, question is this. Find tension. So let's say this is A. B. Find tangent velocity of the ball. All right. C. Find angular velocity of the ball. Okay. In the parenthesis, I'm going to write by RPM. RPM means it's rotation per minute. I'll tell you about that in this question. What does that mean? It's a all question mark. Therefore, guys, what I am going to have. So let's make a rod. Okay, so let's say this is a rod. All right. Then what we have a ball, correct? Which this ball is attached to this string, correct? And this is a rod, all right? And this one is string, correct? And this one is what? Ball. Now, this ball, it rotates around rod and it makes 40 degrees angle. So this angle theta, it's 40 degrees. And guys, pay attention, please. This is very important. And it makes, right dash light, it makes circular motion. There you go. All right. So this ball makes circular motion above the rod. So pay attention here. This is very important section, please. Therefore, guys, this is your circle, correct? So where is the center of the circle? This is center. Am I right? Now what we have to do? What we have to do? Very quickly, we have to verify RTZ. RTZ. What is R? Let me go with a different color. R is toward the center. Oops. R is toward the center. Therefore, this will be actually what? Radial axis or central axis. Don't forget that, okay? What is T? Pay attention. T is on the circle. T is on the circle. It's hard to show it on the board, on the whiteboard. So T is on the circle. T is on direction of motion. T is on direction of motion. T is here on the circle. Okay. It's in the same direction as tangent velocity is. It is tangent on the circle. And remember, R, T, Z. And what is Z? Let me draw it by this color, okay? And what is Z? Oh, no. Yeah, this is Z-axis, okay? So this is radial axis. This tangent axis is on the circle. Z-axis is up and down. Now, all right, what we have to do? We have to apply sigma f on radial axis is mvt squared over r. This is the first thing. Then sigma f on tangent axis is mat. Then sigma f on z-axis is what? Maz. These are whatever we learned so far. Okay. Now, pay attention. Do we have radial or centripetal force? The answer is yes. Why? Because it's circular motion, so this exists. Sigma f on radial axis is mv squared over r. Keep it. What about tangent acceleration? Watch, guys. We assume that Vt is what? Constant. Therefore, At becomes what? 0. We assume, let's say, the ball rotates with tangent velocity and it is constant velocity, so there is no acceleration. Okay, good. So sigma f on tangent axis is what? 0. Very good. So there is no force on tangent axis even. So I'm going to write here no force on tangent axis. Okay. What about on z-axis? Does the ball goes up and down? Of course not. It just goes like this. It doesn't go up and down and then rotate. No, it just goes around the center. So that is 0 also. Correct? Why? Because AZ is 0. Object doesn't go up and down, no motion on z-axis. That's why. Now we have to apply it. Remember, what is dynamic means? Sigma F equal ma. What is sigma F means? Total force. Oh, so I have to verify forces. Let's start it. Okay. I am going with green color. Let's verify forces. Pushing, pulling force. I don't see anything to push, pull. The second force is mg, or force of weight. Oh, okay. So I do have force of weight here, correct? So this is mg. I'm going to write it mg. What is next? Fn, normal surface force. Do we have normal surface force? Do we have surface here? No, I don't see any contact here. Therefore, there is no Fn. Yes, there is no Fn. Good. What else? Tension. Oh, do we have a string here? Yes. So string applies tension. Correct? Tension force. And tension force is what? Toward the hanging point always. So here is hanging point. Therefore, tension is toward the hanging point. I'm going to write here T. So remember, this T is tension force. It's not the period. That's T. And big T must be. You can write by Ft or T. Either works. It's up to you. Okay? What else? I don't see anything else now. Nothing. Okay. Your next step is verify components. Mg is on z-axis, so it has only one component which is on z-axis. It doesn't make any angle, so you don't have like cosine or sine for mg. It's all on one axis, okay? What about t? Let me go by pink color, huh? What about t? Oh, t. So here is your, this is your origin. Oops. Okay, let me go by this. So this is your origin actually. Point 0 is here. So this tension compared to coordinate system, it is something like this, watch. Oh. So this is T. And if this is 40, then how much is this, guys? Then how much will be this angle? This is 40, this is 90. 90 plus 40, 130. 180 minus 130, answer is what? 50 degrees. Do you agree? Okay, so this angle is 50 degrees. Yes. So this angle becomes what? 50 degrees. You know from chapter 3, if anything, if any force, if any quantity makes angle, it has quantity, it has components, correct? So how is the components? Remember, this will be so it's going to be on x-axis. Here you are going to have t cosine of 50, correct? Here you are going to have what? T sine of 50. Am I right? Therefore, very similar. Let's go with red color. Watch, guys. Just go make straight perpendicular from tension here. So this will be what? T cosine theta, cosine 50, of course. And let me make it better. Okay, so this will be T cosine 50. And in the same way, make perpendicular line from tension to z-axis, and this will be direction of component, correct? So this will be what? T sine 50. Let me make it better. Okay. All right. Correct. So this will be T sine 50. So far good. So we verified forces, mgt, then tension makes angle. So this tension has component on x-axis and on y-axis, correct? But our x-axis here is radial axis. Our y-axis here is z-axis. Y is third one, which it is tangent axis, okay? Now we will apply these three things. Okay, let's apply it. Pay attention here. R is radial axis. So any force toward the radial is positive. Okay, look guys, how many forces do you see on radial axis? How many force? Huh? Just one. You see only one arrow. Don't say this is arrow. No, this is for axis. This is for axis, you know. This is like this. This arrow, it's not force. It's just arrow to show the axis. Okay. So, how many forces do you see on radial axis? Only one. It's t cosine of 50. Don't say centripetal force is on x-axis, on r-axis. No, centripetal force is t cosine of 50. So if r, how many forces do you see on radial axis? It's just one. What is that? It's t cosine of what? 50. That's all. Some students, they write, okay, we have t cosine of 50 and also we have centripetal force. No, actually this t cosine of 50 is same as centripetal force. So you have only one force, which this t cosine of 50 is forms by centripetal force. So do not write this, okay? So please be careful about this. One more time. How many forces do you see on radial axis? It's only one in this problem. What is that? Just that arrow. That arrow is t cosine of 50, so I'm going to write t cosine of 50 here. Okay? Do you see any other force? No. And this t cosine of 50 must be positive or negative. What is your answer? Answer is positive. Why? Because it's toward the center, and anything toward the center is what? Remember, it's positive, guys. Okay, so I don't put that positive because it's positive. So t cosine of 50 is equal with m of tangent velocity to the power of 2 divided by r. So I wrote this. Now I'm gonna go force on tangent axis. Do we have any force on tangent axis? No, because object just rotate. There is no friction, there is no drag force, there is nothing. Okay, so the second one doesn't help me. Sigma ft is 0. So I'm going to write no force on tangent axis. So this doesn't help me, okay? Now sigma fc, this one. How many forces do you see on z-axis, guys? 1, 2, 3, what? 3? Why? Maybe your answer is this mg, green one, then this red one, t sine of 50, and z, correct? No, be careful. Some students say z is force because it's arrow. No, z is just axis. Your forces on z-axis are mg and t sine of 50. And remember, anything upward is positive, down is what? Negative. Therefore, I am going to have t sine of 50, correct, is equal with mg. Am I right? Therefore, let me move my picture here. Therefore, guys, I can, oops, I can have, what is wrong with this? T cosine of 50 equal mv square over r, and the other one, so this is, and this one, t sine of 50 equal what? Mg. So far makes sense or not? Please let me know. This is set. Now you're going to substitute to see what's going on. Let me open a new page. So what I have, I do have t cosine 50 degrees is equal with mv squared over r, and t sine 50 is equal with mg, correct? So, guys, you know, I don't have speed. Actually, speed is unknown. I have to find velocity. I have to find tangent velocity. So let's put 1t here. Okay. So here in the first equation, I have two unknowns. But in this second one, I think I can do something. Watch. I can say t is what? mg divided by sine 50 degrees. Why? Because I know mass, I know g, I know sine of 50, so tension becomes mass. How much did they give you mass? Mass of the ball is 500 grams. Mass of the ball is 500 grams. Remember, you have to convert it to kilograms. 500 divided by 1000 will be 0.5 times 9.8 divided sine 50. So the answer will be, let's see, 0.5 times 9.8 divided by sine 50. The answer is 6.39. So tension is 6.39 newtons. This is my tension. So far makes sense? They want me to find, what is that? Velocity, find tangent velocity. Okay, let me move this here. So using first equation, this one, I can find velocity because I have tension now, correct? So I'm going to substitute 6.39 times cosine of 50 equal what? Mass is 0.5. Velocity is unknown. So let me write Vt divided by what? R. Oh my goodness. Do we have R? Do we have R? Do I have the radius? No, I don't. So guys, I suggest you this. Always, the first thing that you have to do in these circular motion problems, first look for angles and then radius. Okay? We don't have the radius, but we can find it. Let me write you here that length of string, I didn't give you that correct, is 1.6 meters. So what I have, watch it, I have something like this, correct? This is 1.6 meter, and then this angle question says is 40 degrees. This is the radius. How can I find radius? In this triangle, I can find radius. How? Using trigonometry. This is triangle, your opposite is unknown, your hypotenuse is 1.6, you do have angle, so if I use sine of 40, correct, is equal with opposite, which is r, divided by hypotenuse, which is 1.6, therefore radius will be 1.6 times sine of 40. The answer is 1.02 meters. 1.02 meters. Okay, let's put this one here. Therefore, right here 1.02. Then guys, let's see what is the tangent velocity. So I'm going to do 6.39 times cosine of 50. Okay. Times 1.02, correct. Divided by 0.5, correct. then take square root, will be 2.89 meters per second. 2.89 meters per second. This is tangent velocity. I think this is part B. We found tension, part A. Then it says find tangent velocity. Okay, we did it. Now part C. Find tangent velocity. Then part C says find angular velocity. Okay. What is angular velocity in part C? This is part B. This was part A. Right, by different color. Guys, they want us to find omega. Oh, okay. We do have VT, we do have R. So what is the relationship between VT and omega? Is it not VT equal R omega? Therefore, omega becomes what? VT divided by R, which VT is 2.89, divided by R, which it is 1.02. Now, if I do omega will be 2.89 divided by 1.02, the answer is 2.83. 2.83 what? What is the unit of omega? Do not forget this. Radians per second. Okay? Keep it in your mind. Unit of omega is radians per second, so 2.83 radians per second. Let me tell you one important thing. Watch. Guys, do you know what is omega means? You see it omega every day in your life. Do you know what is omega means? Omega is same as RPM. What does RPM means? Revolutions or rotations per minute. RPM. How many rotation you have in 1 minute, how many rotations we have in 1 minute, that is your omega. RPM is not metric unit for omega. The metric unit for omega is radians per second, but we can derive, we can find radians per second by rotations per minute. Let me tell you this. Watch it. One rotation, as you know, how many pi is one rotation? It's 2 pi radian. You know, one circle, one complete circle is 2 pi radian, correct? So one complete circle is one rotation. So one rotation is 2 pi radian. And then we need second. 1 minute, you know, it is what? 60 seconds. Therefore, question says what? Find omega by RPM. Find omega by RPM. Okay, how much was omega? Is 2.83. Now I am going to write omega is 2.83 radians, correct, per second. Am I right? I will convert this one to RPM, rotation per minute. Watch guys, I want to convert radians to rotation, so I'm going to write radians here and revolution here. Okay, so we know one revolution is what? 2 pi radian, correct? Then second to minutes, so I'm going to write second here, minutes here, correct? 1 minute, as I know, it's what? 60 seconds. Now, as I see, this radian with this radian gone, correct? This second with this second gone, am I right? Therefore, my answer becomes 2.83 times 60 divided by 2 pi revolution per minute. Therefore, omega, this is very important. I want you to practice this problem again. So omega becomes 2.83 times 60 divided 2 pi. The answer is 266 or 67. Okay, 266.7 RPM. You will write here RPM. That's mean is, it's a very big number. That's mean is this ball rotates 266 rotation or revolution in 1 minute. Okay? So please watch this video very carefully, take the note, do this problem again, write equations carefully, memorize equation, understand the concepts, watch some video that I told you please, and on my next class I will go over problems of circular motion above dynamic. Okay guys, hope you enjoyed, hope you like these equations, this motion, this dynamic, and this lecture. See you later. And chapter 6, 7, 8 almost done. There is one more topic, it's about gravitational force. But first I want to go over some problems from chapters 6, 7, and 8, and then I will go over gravitational force. Okay? Have a good day, have a good night, have a good week, weekend, everything.